12.6 is the section we're dealing with, and it's nonlinear systems of equations. All right, so nonlinear systems of equations, a little bit more difficult than linear systems because we can't use the matrix stuff on it. So that makes it a little bit more difficult to do. You've got to do a little bit more algebra stuff in there, but you kind of can catch on to some of the tips and tricks here. It's not easy, but it ain't hard. Of course, I'm one to talk. It happens. All right, so when you're dealing with nonlinear systems, there's a couple of different ways to approach it. The methods that I try to use are substitution or elimination. And it really doesn't matter which one of those you use. Most problems can be done with either of them. Some of them are a little easier to do with one than the other. With this system right here, it looks like it would be a good candidate for either one. It's not really advantageous to do one over the other for this problem. So I'm going to look at it in with the substitution idea, which I think makes the algebra a little bit cleaner on this one than the elimination does. Okay, so the idea is that you're trying to solve for both variables at the same time, the same way we did with linear systems. The only difference is we can't take that shortcut with that RREF stuff. So what we've got to do, or one of the strategies, if we're going to use substitution, which is what I'm going to try to use for this one, I'm going to take one of these equations and get a variable by itself. And what I try to do when I'm using substitution is look for one that would be easy to solve for a single variable. And either of these would be pretty easy. The first one, I think, would be a good choice because we're used to getting a problem like that with y by itself. We're used to doing that. So that makes it a little bit more familiar to us. So I'm going to take this first equation and I'm going to solve it for y. So I'd have 3x minus y equals negative 2. And I'm going to get y by itself. So I would subtract 3x. And then divide by negative 1. 3x plus 2. So I've got y by itself. Now, the idea of substitution is that now that I know what y equals, I can take that part and substitute it in the place of y in the other equation. And then I have an equation that looks like this: 2x squared minus parentheses 3x plus 2 equals 0. And that is an equation that only has one variable in it. It has only got x's in it. So that's doable. When we've got two variables in there, it's very difficult to solve for a single answer out of that. So this gives us a fighting chance at it. So the first step that I would do would be distribute the minus sign. And then it leaves me with the quadratic, which is what happens a lot of times with the nonlinear systems, is you get a nonlinear equation to solve. So here we got a quadratic, so we got to go back to chapter 4 and think about how do we solve quadratics. So our options are either factoring or quadratic formula, either of which will get you the same answer on this one. This one does factor quite nicely. If I do factoring, be negative 4 and add to be negative 3, that'd be negative 4 and 1. So I could do 2x squared minus 4x plus 1x minus 2. And then group 2x, x minus 2 plus 1, x minus 2. So my factors are x minus 2, 2x plus 1. And I set each of those factors equal to 0. Get x equals 2, and x equals negative 1/2. Those are my two x values that I get with this problem. Well, I got two different x values. That means I should get two different y values with this problem too.
How did you get to x plus 1? Can you explain that?
All right, so at this step, when I did the grouping, I factored out the GCF of these two, which was 2x. That's that right there. That left me x minus 2 in parentheses. Then the only thing that goes into both of these is 1. So that's where this plus 1 that came in the front is. That's the GCF of those two
You just
terms.
did the front one.
The front ones is one factor. The matching one is the other factor. That's what it's been a minute since we factored. 3 weeks, I think, at least that long. Okay, and so then we got our factors, and we just set them equal to 0. So I got two different x values. That means I probably should get two different y values that go with those. So what I'm going to do is take those answers and one at a time plug them into an equation that's got a y in there and get what the y value is. I've got a nice one right here that just says y equals 3x plus 2. So I'm just going to take those and put it into that one because that'd be the easiest one to get answers from. So if I do that, 3 times 2 plus 2, be 6 plus 2 is 8. So 2, 8 is an ordered pair. And then I'm going to do the same thing with the negative 1/2. I have a calculator open here, so I'm going to try to get that open. And that's going to be negative 3 over 2 plus 2, which is 4 over 2. Should be positive 1 over 2. So the other ordered pair would be negative 1/2, positive 1/2. And we found the ordered pairs are what we're finding here, is where the two, and what it ends up being is where these two things cross. If you were to graph both of them, is what you're finding there. But substitution method works quite well on a lot of these. They're not going to get anything too strenuous on you to solve with the nonlinear systems, but they do. Substitution gets used a good bit. And then we'll do another example that does the elimination. I'll show you what to do with it. It's not really back. The elimination is about the same. So you're just trying to get one variable by itself first, and then get the other, and then plug it back in to get the other one. That's your goal out of this. All right. So let's look at another one. We'll use the elimination method on this one, just so we can say we've used both. But this one really leans itself well to the elimination method. Elimination is real handy when you don't have a plain variable, as in you don't have something that's just plain y or plain x. Everything's got an exponent on it. So elimination is usually when you're going to want to use that is when you have something like this where you got an exponent on all your variables. And the way elimination works is you're trying to cancel out either the x squareds or y squareds or the matching pieces. Okay, so we have a positive x squared and a positive x squared. Well, they don't cancel each other out, but here we have a positive y squared and a negative y squared. They're opposites of one another, so they would cancel each other out if I add the two equations together. And sometimes you might have to multiply one of the equations by something to get the opposites to happen. You might have to multiply one of them by 3 and the other one by 2 or something. Sometimes you got to multiply one of them by a number. Sometimes you got to multiply both of them by a different number to get an opposite on the same variable. This one, they're already opposites. One is positive 1y squared, one's negative 1y squared. So when you add these two equations together, the y squareds go away, and x squared plus x squared would be equal to what? What's x squared plus x squared? This has to be 2x squared. And then on the other side, we got 13 plus 7, which is 20. Now, what we've done is created an equation that only has x's in it. Same idea as what we did with the substitution. So we see where they're really the same thing. One just looks a little different. Okay. So because we got only x's, I can just try to solve that for x. I want to divide by 2 because everybody's divisible by 2 there on that problem. So that gets me x squared is equal to 10. And again, this is the quadratic, so we got to think about our ways to solve a quadratic. One way is factoring, another way is quadratic formula. But this one really would be easiest to do by square roots, because I don't have that plain x piece in there. So that makes this one easy to do with square roots. So I'm going to take the square root of both sides. That'll give me x. And then on the right-hand side, I've got a positive and a negative square root of 10. That's 2 different answers for x. Okay? 2 different answers for x means I'm going to get 2 answers for y from that x. May get more than that since his y's are squared too. So what I'm going to do is I'm going to plug in the positive square root of 10. I'm just going to go to the first equation because it's got all positives in it. That may be the easiest one. I don't know. Really, neither one of them are real pretty, but as far as real quick and easy problems. But if we plug that in there, what happens when you square a square root? What happens to that piece right there? They cancel out and it just gives you a 10. And now we got 10 plus y squared is equal to 13. We want to get y by itself. That's our job. So I'm going to subtract 10 from both sides. That's y squared is equal to negative, or no, positive 3. And that looks a lot like the problem down here. It's just got a y in it. So I'm going to take the square root of both sides. So I get 2 different y values from that one x value. So from the x value of positive square root of 10, I get a positive square root of 3. And then I get a positive square root of 10 with a negative square root of 3. So I've already gotten 2 answers for this one from the first x value. I bet I get 2 answers from the other x value too. Because I'm going to do the exact same thing. I'm going to take the negative square root of 10 and square that plus y squared is equal to 13. So again, I'm just taking the x values that I found and plugging them back into one of the equations. It doesn't matter which one, just try to get one that would be easy to solve. And these are about the same either way. So what happens when I square the negative square root of 10? Same thing. Cancels out. Negative times negative turns to positive 10. And looks like the same problem, but the x value that I used was different. So take the square roots. So I get negative square root of 10, positive square root of 3, negative square root of 10, negative square root of 3. So this one has 4 solutions to it, or 4 ordered pairs out of that. And kind of thinking, where we're at with this and what we're doing with it, we're taking multiple choice quizzes, multiple choice filing them. The idea is, those ordered pairs, if we plug them back into both equations there, they should work in both of them. All 4 of them do for this one. So that's kind of your check to this, is look at the ordered pairs that are a solution and then plug in those answers, those ordered pairs into the problems. If it doesn't work in one of them, it doesn't matter if it works in the other one or not. We know that's not the answer. Just go to the next step. Go out of that. So nonlinear systems, substitution and elimination are great ways to solve those and really seem to be a great start to things. All right, let's look at, I'm going to swap to graph paper here. I'm going to show you how to do this with the calculator too, but I want to draw it by hand. I think it helps us to kind of see things. So I'm going to pop on some graph paper here. All right, got old graph paper. This is 12-7. Systems of Inequalities. So inequalities are a lot like equations but their graphs are a lot different because equations are just going to be the lines. Inequalities puts in this shading idea of stuff that has to be shaded. Draw semi-straight lines with the ruler sometimes. All right, so let's take a linear system first. We hadn't done any of those, so let's take a linear system of inequalities. Let's say we had y is greater than 3x minus 7. And then the other equation or inequality is y is less than or equal to negative 1/2 x plus 5. Okay. So the idea here is that you would take each of these inequalities and graph them on the coordinate plane. That's what we're doing. And the shading of these two graphs will be the answer. Like the entire graph is the answer. I'm going to show you graphing these by hand, and then I'll show you how your calculator can kind of help you do this. So the first one, we got y is greater than 3x minus 7. So that's in slope-intercept form. That's the way we want it if we're going to graph it. So we'd go down to negative 7. And then we'd go up 3 and over 1. And then that's pretty much where it stops being like an equation. Because the next step, you've got to decide, is that a dotted or a solid line that connects those dots? And the way you decide is if it has an equal to mark, it's solid. If it doesn't, it's dotted or dashed. So this is going to be a dashed line. And what that means is these ordered pairs that are on the dashed line are not solutions. They don't work for that inequality. So be careful of that the dotted lines and the solid lines make a difference. And most of the time, like on a multiple choice situation, we're going to have the same graph, and one of them will have a dashed line and the other one will have a solid line there. And it looks exactly the same other than that. So you've got to be careful about those sort of things. So just remember, if it's got the equal to mark, it's solid. If it doesn't, it's dotted when we're doing yes, that's right. It does not equal that. So it means the points that are on this line are not solutions to that inequality. That's what that means. All right. And now we got to do some shading for that because it says where the y value is greater than 3x minus 7. So what we do is we can take a test point and check it in that inequality. So what you would want to do is pick a test point that's on one side of that line. I'm going to pick 0, 0 because that's a really easy one to plug in. If the line doesn't go through 0, 0, that's the one I'd use every time. If the line goes through it, just pick a different one that the line doesn't touch. Okay. So I'm going to test 0, 0 in this problem. So I'm plugging in 0 for x and 0 for y and deciding if that's true or false. Is 0 greater than negative 7? No, that's false, isn't it? Because that's false, I'm going to shade the other side of that line. The shading would go this direction. That's what would happen. And like you would, all of these points over here are solutions to that inequality. That's what I'm showing there. That would be the shading that happens. I'm just going to point arrows and say shading that way because I got to draw another line on here for this other inequality. And so it helps me to be able to just get a little better looking picture if I don't shade everything. Okay. So I plugged in 0, 0. That's the test point. It was false and it's on the left side of the line. So that means everybody on the right side of the line had to be true, right? Wait, I said that wrong. 0 is greater than negative 7. No wonder you're looking confused. It's been one of those days, kids. Maybe I just can't count. It's been a rough couple of weeks. So. Sorry about that. So it should go that way. That's true. That's not false. That's true. Video evidence that I'm dumb. So good. My wife already had some of that, so it's okay. All right. Now, so the shading would be on this side of that line. That would be all of those points would be true. All the points on the right side are false for that particular inequality. I'm not going to shade all of those. I'm just going to point arrows saying that way. And then I'm going to graph this other inequality on the same coordinate plane and see which direction I shade with it. So it's got a y-intercept of 5, 2, 3, 4, 5, and a slope of -1/2, so that'd be down 1 over 2. And it has an equal to mark, so what's that mean about its line? It's not dotted, it's solid line. So it looks something like that. And then I want to check a test point to see which direction to shade here. If I plug in 0, 0 as my test point again, I can use that one because the line doesn't go through it. Remember, the test point cannot be on the line because that doesn't tell you anything if it is, as far as which direction to go. Is 0 less than 5? I think I got my head on straight this time. I think 0 is less than 5, right? 0 is less than 5. Maybe I should have just stayed on today. So that would mean it's true that direction. Okay. So all the shading for this line here goes south, right? The overlap is where the solutions are. So where are they overlapping? They're overlapping in this kind of this area right here. There we go. In this area over here. So that's the area that I'm going to shade. So I'm going to. So these are my solutions. This is the solution area right over here. Okay, where the overlap happens. Sorry about that. My first mistake today was getting out of bed. No, it hadn't been a really great day. There have been many more after. But I'm thankful I was able to get out of bed. Could have been worse. Could have had to teach high school all day. Wait, I did. We had about 17 people vaping in the parking lot this morning. I don't know if it's that many, but it was a cloud of witnesses, that's for sure. Yeah, they got all got. SRO busted them. In the parking lot, he pulled in. They're
rolling, huh?
I'm like, y'all are dumb. She just went up here to. I guess they don't. Yeah, I will say that it's better than regular cigarettes and stuff. Gosh. All right, let's look at this one. This one has a linear component and then a nonlinear one together. So we're going to graph both of those. And before we move on, let's go back and do these two on the graphic calculator so I can show you how the calculator can do that. All right, so the dotted and the solid, you really got to just know that. But as far as the shading goes, you can get a little help with the calculator. All right, so I'm going to type in the first equation or inequality that we did on part A, which was y is greater than 3x minus 7. So 3x minus 7. All right, so I notice I didn't change that inequality to an inequality symbol. Unless you're running an app, which you're not supposed to use, you can't change that to a greater than symbol. What you can do, though, is tell it which direction to shade. And the direction you shade is based on the inequality symbol. So it's a greater than symbol. So greater than should be a bigger than, right? So that would be up. So you want to hit enter. If you got the black and white version, you're going to hit enter until you get the little triangle there. It should just be once or twice that you have to hit it. You guys all have that version. Let me change mine to that version. All right, hey, that's where I've done some of that. Let me clear those out. And so I'm going to go back to the old black and white version here. 3x minus 7. So 3x minus 7. And I'm going to go over to the left all the way to where that is. And I'm going to hit enter until I get a triangle in the top half. That's the greater than shading is what that is. And then when I hit graph, we see that shading that we were talking about that we drew by hand. And then I'm going to go to y2, and I'm going to put in that negative 1/2 plus 5. Negative 1 over 2, 1 over 2 x plus 5. And then it was a less than or equal to. I've just got to know that it's a solid line, but less than is going to be the lower shading. So I'm going to hit enter until I get that bottom triangle. I'm going to hit graph. And there we see that overlap is the darker region of that. So it'll kind of draw the graph for you there. You've got to just know the dotted or solid line part, but you can get the picture there. So greater than y greater than is going to be the upper triangle. Y less than or equal to is going to be the lower triangle. When you go to graph that with the calculator, works out pretty nice. All right, let's look at example B, number B. All right, so this one is, we got a quadratic and we got a linear. I'm going to get this one in slope-intercept form, negative x plus 2, so that it's easy to graph. And then I'm going to graph those on the coordinate plane. I'm going to do it by hand, and then we'll do it with the calculator too. So for the quadratic, that's the first one that I'm going to do. I could pick some x values, plug it in. Also, just know about quadratics that's what shape it is. I know that the y-intercept would be negative 4, and I could pick some x values to go from there, like negative 1. Plug that in. 1 minus 4 would be negative. I'll just put that at negative 4, like it's supposed to be. Negative 4, and then negative 3, and then plug in 1, it'd be positive, or positive 1 would be negative 3 as well. If I plug in negative 2, that'd be 0, and if I plug in positive 2, it'd be 0 as well. So I get this shape going on, and it's got an equal to mark, so I know it's a solid line. So it's that parabola shape happening there. And then the next thing to do is the shading for that parabola shape. And the shading, it's the same idea. You pick a test point, and you're either going to shade inside of the parabola, like in this inside of the U, or on the outside of the U. It's either inside or outside. There's no in between. So I'm gonna pick 0, 0 as my test point because it's right there in the inside of that. If it's true, then I shade the inside of the parabola. If it's false, shade the outside. So 0 greater than or equal to 0 squared minus 4 is 0 greater than negative 4. I'll let y'all answer this because my track record is not good today. Yeah, it is. Okay, it's true. So we're going to shade toward the inside of this parabola. That's the direction we will shade. So I'm just putting some arrows telling me that's the direction we would shade for that one. And then I'm going to graph the linear equation. I got it in slope-intercept form to make it easy on myself. So there's the y-intercepts 2, slope of negative 1. And it's got an equal to mark, so that means it's what kind of line? Dashed or solid? Solid. So it makes it easy to draw. And then I'm going to check 0, 0 again because the line doesn't go through it. So 0 less than or equal to negative 1 times 0 plus 2. Is 0 less than 2? Yeah, that's true as well. So I'm going to shade this direction on it. The overlap is this weird looking shape right here, kind of in the middle there. I don't know what shape you call that, but a slice of the parabola. So So your shading would be, the solutions would be in this area. So any ordered pair that's in that shaded area works in both of those inequalities. That's what that means when we find that, is that any ordered pair in the solution area works for both inequalities. Okay. Let's look at it on the graphing calculator real quick, just to make sure we're on track with that. So we've got x squared minus 4, x squared minus 4, and then it was a greater than or equal to symbol. So I've got the right triangle on that one. I don't have to change it. And then I'm going to go to the next one, and it was a negative 1x plus 2, and it was a less than symbol. So I'm going to change that to the lower triangle and hit graph. And there we see roughly the same picture that we drew by hand. Nice and pretty. So ways that they can ask questions about this. One would be the graph, like the solutions to this system of inequalities would be the whole graph drawn. Another one would be, way of asking questions about this would be, which one of these ordered pairs is a solution to the system of that? And it works the same way as the equations does. If it works in both of them, then yes. If it only works in one of them, then we got to look at where it's at in the solution area, that kind of idea. So the graph really is key on the systems of inequalities. Use the calculator to help you graph a little bit when you don't, when you're looking at these. Should help out a lot. Make sure upper triangle is greater than, lower triangle is less than. The equal to mark, remember, makes it a solid line. No equal to mark is a dotted line. And the dotted line means what? About the points on that line. They're what? They're not solutions to the system. That's what that means. So a lot of times when it's a multiple choice type situation, they'll throw an ordered pair in the list that's on a dotted line and try to catch you. Because sometimes if it's on a solid line, it is a solution. If it is on a dotted line, it's not. So be careful of that when you're looking at these problems, but plugging in values there. All right. Really, really short evening. This is one of the last things. I'll show you what I want you to know about section 12.8, linear programming. We're actually not going to do a lot of the programming ourselves here. We're going to do kind of an ode to linear programming. not really going to require a ton of you out of this. But linear programming, one thing that you'll have is what's called an objective function. An objective function is the what that means is that's your checking function. And you're going to either find the maximize or minimize the objective function. And what you're going to do is you're going to take these things called constraints. And constraints are inequalities that form a polygon. Remember back in geometry, a polygon is a closed figure. It's got corners. It's got vertices, is what those corners are called. These constraints are inequalities that are graphed. So it's a bunch of inequalities that create this polygon that we're going to use the corners of to maximize or minimize the objective function. And they'll tell you which one to do out of that. So let's look at an example of that. So here's Here's our objective function. I equals 0.02 x plus 0.03 y. That objective function is not graphed. You just wait, leave it sitting there. We'll use it later, okay? But they'll give you an objective function to either maximize or minimize out of that. And then they'll give you these things called constraints. And the constraints are a list of inequalities. So our inequalities that we're going to have are x is greater than or equal to 0, y is greater than or equal to 0, x plus y is less than or equal to 25, and then x is also greater than or equal to 15, and y is less than or equal to 5. Those are the list of constraints. So we got 1, 2, 3, 4, 5 inequalities that we would, if you were going to do the entire linear programming game, you would graph all of those. Okay, here's what's going to happen with 140 this semester. I'm going to give you the graph already done. Okay, so you've got this. This is what you're going to get. You're going to get a picture that has all these constraints. It'll have them listed there, but I'm going to go ahead and graph it for you so that you've got this kind of picture going on. And I'm just going to kind of rough this in to give you an idea about what it looks like. Let's get that right there. And then let's do that. And what happens here is you create this polygon that is the overlap of all those inequalities. That's what that polygon is. So you're going to get that polygon given to you. And the corners may or may not be given to you. If the corners are not given to you, it's going to be on a coordinate plane. You're going to be able to count over and get the ordered pairs that go there. So you're going to get the ordered pairs that go with these. So that ordered pair right there at that corner is x value of 20, y value of 5. At this corner, it's an x value of 25, a y value of 0. If at this corner, it's 15 for x, 0 for y. And then this last corner or vertex is 15, 5. Okay. Now, if we were doing all out linear programming, then you would have to graph all of those and then use a system of equations to find the solutions to those where they're crossing and all that stuff. So it's quite an extensive process if you're going to do that. But the key is having those corners of the polygon. If you got the polygon, get the corners of the polygon. Use those ordered pairs of the corners to either maximize or minimize the objective function, whichever one they tell you to do. We're going to do both with this problem. We're going to maximize and minimize this. So what we're going to do is we're going to take those ordered pairs, and it doesn't matter what order you do. I mean, I'm just going to start with 15, 5, and I'm going to plug it into my objective function. And I'm going to work out and get the answer to that. All right, so it'd be 0.3 plus 0.15, which would be 0.45. And you can use a calculator to do that. It doesn't take, it's just, we're just taking these ordered pairs and we're plugging them in. 0.02 times 15 plus 0.03 times 0. So x and y value, so that'd be 0.30. And then 20, y value of 5. I'm going to plug that in there. 20 for x, 5 for y. It's going to be 0.4 plus 0.15 is 0.55. And then one last ordered pair. That's the 25, 0. We're just going to plug that in. 0.2 times 25 plus 0.3 times 0. 0.50. Okay. Your minimum will be the lowest value. Minimum of 0.3 at what ordered pair? 20 or 15, 0, right?
The objective function is different for every problem?
Yeah, it'll be different for each problem. You don't have to memorize that. It's going to be different. They're going to give you an objective function and say maximize or minimize this function, and you just plug it in. That's really exactly what's going to happen. And they're going to give. I'm going to give you the graph, and you just use those ordered pairs and go. It's really an easy thing. If you got to do the full linear programming, we could spend a couple of weeks doing that. I don't see you guys doing that very much outside of this class. I mean, honestly, our maximum was 0.55 at the ordered pair 25. And that's what we're finding is either the maximum or the minimum. They're going to tell you which one to do and where's it at. They may say where is the maximum at, and based on that. What this is used for is like if you're doing like a manufacturing or a cost analysis type thing, you might have several different equations going on, or inequalities in this case going on, and you're trying to maximize your profit. Maybe you've got a profit function that you know this about when we sell this particular part, we make this much money off of it. When we sell this particular part, we make this much money on it. You might be trying to maximize your profit or maximize your revenue, that sort of idea. And linear programming is kind of used in that sense. Sometimes I'm trying to come up with a medical example, and I don't know enough about it to even start to get that. But I'm imagining that there's some sort of charts and graphs that you could use with all this medicine that you're giving people, and you could find the maximum benefit for a patient based on that. I don't know that anybody does that by hand anymore. I'm pretty sure you don't. Most of us have a computer program that does all this stuff for us now. And we hospitals and medical facilities pay tons of money for those sort of things. Which is, I should have been doing that, writing those programs. They've been fun. All right, so you have quizzes for these sections, and then your Chapter 12 test. Chapter 12 test, I won't make it due until the 9th. So you'll have 2 weeks to be able to do that. Same for the quizzes. I won't make those due. So you've got plenty of time to do those things. You've got the 2 different final exam practice exams to look at.